Hi everyone, so today we're going to learn about the number e. So look at the compound interest formula, and we want to look at what happens to the multiplier, or what's considered the base of your exponent, as your n, which is the number of times that interest gets compounded, as that number gets larger and larger. So you're going to notice the base of the number as it continues to increase. And what you should find is that the value of the base actually approaches the number 2.718 as our n value gets larger and larger. So what we actually do is we call this number 2.718, we call this number e. And e is actually an irrational number, so it's similar to pi. Now, if interest gets compounded continuously, meaning that the value of n kind of approaches infinity as it gets larger and larger, we actually use a different interest formula that involves this number e. And so this continuously compounded interest formula, we do use that number e. And so these variables each represent something different. Now our P represents our principal amount, or the starting amount, so whatever the amount that we invested. R is again that interest rate, so that's going to be in decimal form. And T is always going to be our time. And the A is going to be the final amount, or that ending amount. Now, you can find the number e, that 2.718, on your calculator. So if you press the second button here, and then you press the division sign, you're going to notice that you're going to get the number e. So here we have a question where Estelle received a $4,050 bonus, and she plans to invest this money for 4 years in one of the following accounts. So we want to determine which account she should choose to earn the greatest return. So now let's look at account letter A. Now account A says our interest is going to get compounded continuously. So there you go, there's your keyword, continuously, so you know which formula you need to use. Now you have your two pieces of information as well. You have your starting amount, which is at $4,050, so that's the amount that gets invested. E is going to be that number, that 2.718 number. Our R is our rate, and then that T is the time, which is the 4 years. Now we're going to go ahead and put that information in, remembering that our rate is going to be placed in decimal form, so 0.052. And when we plug that straight into the calculator, we're going to get $4,986.41. So that's for account A. Now, if we look at account B, the interest in account B gets compounded monthly. So there is our keyword, which is monthly. And so we're going to use our compound interest formula. So because we know monthly, so n is going to be 12, so the number of times in a year that interest gets compounded. You know your rate, so 5.3%, or that is a decimal. And then again, you know the time, which is still 4 years, as well as the principal, or that starting amount. So we're going to plug that information into your formula here. Now, when you plug that information in your calculator, you're going to get $5,004.06. So Estelle should actually invest her money in account B to earn the greatest return. Okay, so now when you look at graphs, now E represents 2.718 approximately. So something to know is that because this base is actually greater than 1, the graphs involving the number E are always going to be exponential growth functions. Now we're going to look at this first graph together. This is actually the parent function. So it's just E, which my base, to the x power, so E to the x. What we're going to do is when we plug that into our calculator, we're going to get some numbers in our table of values. We're going to plot those points, and you're going to notice, just like exponential growth functions, you're going to have a curve that is increasing. Now, with your parent function with exponential growth, you're going to have your horizontal asymptote be right at y is equal to 0. With this, you're not going to have an x-intercept, because that asymptote actually hinders the graph from actually crossing. So you're going to write none. For my y-intercept, we can actually get that from my table where my x is 0, my y is 1. Domain's always going to be all real numbers for my exponential functions here. And my range, depending in this case of my horizontal asymptote, is going to go from 0 to infinity. So now let's look at another example that has some transformations. Now you notice that your base is going to be e raised to the x power. So that's, again, noticing what we just looked at is your parent function. Now you actually have two transformations on here. The first transformation you should see is right on that exponent, that +1. That's the inside of my function. So that's going to be going to the left 1 because it's opposite. And then that -4 outside the exponent is going to go down 4. So when you plug the function into the graphing calculator, you're going to go ahead and get a few numbers for your table of values, and we can go ahead and plot them and then again draw my curve that's increasing. Again, remembering that you had a transformation that shifted down, that's going to impact your horizontal asymptote, which is now going to be at y is equal to -4. Now finding your x-intercept, now it's not a nice point here. What you're going to have to do is you're going to have to go to the calculator and you're going to have to trace that 0. Remember, 0 is another name for your x-intercept. You're going to get 0.39. Your y-intercept you can get from your table, which is -1.28. Domain, again, all real numbers. And my range, again, based off of my horizontal asymptote here as -4. Notice that it is a parenthesis, so it's not including, going all the way towards positive infinity. Now here are some things for you to remember. Remember that the parent function for the number e, so e to the x, has a horizontal asymptote at y is equal to 0. And because that number e is approximately 2.718, the graphs are always going to be exponential growth functions. Now I hope this video was helpful and you learned more about the number e and how to use it in not only a formula, but also how to graph it. Thanks for watching and have a great day.